once again. So we have last technical session, that is panel discussion for this conference, which I would like to start with a few lines of German-American rocket engineer Warner Brown. He said, "Research is what I am doing when I don't know what I am doing." So research has lot of opportunities, lot of uncertainties. So now we have technical panel discussion, that is transforming Indian standard to performance-based durability design of concrete structure. I would like to invite our distinguished panelists on dais. I would like to start from Dr. V. Ramachandra, President ICI and UltraTech Cement Limited. Professor KVL Subramaniam, IIT-Hyderabad. Dr. Jagabandhu Kole, Head R&D, JSW Cement. Professor S.K. Singh, Chief Scientist, CSIR-CBRI. Shri Shailendra Sharma, ex-DG, CPWD. Shri P.N. Ojha ji, Joint Director, NCB. And to moderate the session, I would like to invite Professor Shashank Bishnoi, Professor, Department of Civil Engineering, IIT Delhi. Now this dais to Bishnoi sir. Now hand over to you, sir.
The microphone, yeah, it works now. Thank you so much. Good afternoon, everyone. I'm very pleased and honored to be in the middle, actually exactly in the middle of such a distinguished panel. And the job of most of the moderators is to make sure that we finish on time, we're doing everything properly, we're doing everything properly. I want to try and make these people fight today with each other. So let me see if I'm able to achieve that. Today we have, you've already heard the introductions. What we're going to talk about today is about transforming Indian standards towards performance-based durability design of concrete. And although we say concrete, there's a lot to be done in the area of cement as well. Cement, concrete, everything has to be covered in that. But before we, before I go to the panelists, I want to say a few things. We know we have IS 456 as the concrete code in India, and all civil engineering students have to compulsorily read IS 456 in school, understand it, in college I mean, before they can claim to be civil engineers. There are many different things that are suggested in IS 456 for getting good durable concrete structures. We at the moment are in the process of revising this IS 456, and several of us sitting here are members of various panels where we are revising IS 456, and the durability part is definitely a very important part, and it's not going to be easy to revise that durability part, because durability is not easy. As civil engineers, we are very used to saying that I want to make this huge building, and I want to make sure that this building will be able to take the load of 500 people sitting over there and 25 people dancing over here. We are very used to saying that, but we are never used to saying that this building should be able to take the load of 500 people sitting over there and 25 people dancing over here 75 years from now. That is something that we have not been very used to saying. And this is what the standards have to answer as to how to design our structures in different conditions. I was saying this during my talk yesterday. The same material will not work in different conditions. The same material that works in Delhi will not work in Kedarnath or in Chennai or in Mumbai. It has to be different kinds of structures that have to be there. But other than the materials, there are a lot of other factors also that play a role. And that's where we would like to get the knowledge and learnings from Shri Shailendra Sharma Saab, who has been the DG of CPWD earlier. And I would like to understand from you, sir, what do you think are the main concerns in durability? Why do you think we end up with so many structures that are not durable?
Hello. Am I audible? As we all know, durability of the concrete structures basically depends on multiple factors. The aggressive agents which might act on the concrete can be physical, chemical, biogenic, but in my experience, the most destructive kind of, the most adverse kind of action which has taken in concrete, basically RCC, more in RCC, because when the aggressive agent penetrates the concrete and reaches the reinforcement, and then that rust, that creates the main problem. Most of the time they have been either, mostly they are intrinsic. They are when the water testing has not been done properly, or the aggregates and minerals, they have not been tested properly, and there is chloride, sulfate, fluoride, etc. in it. So they have caused the biggest havoc in most cases. The other thing is that basically concrete is a porous material, we know, and it depends on the initial permeability and porosity. If the concrete is not placed properly, compacted properly, or if it is not even designed properly, that creates a basic problem in the concrete itself, and particularly if it is exposed to aggressive environment, or even if it is in a wet area where water is frequently coming, like in toilets or terraces, and it is not properly maintained, then this leads to problem. These are the main factors which I have found to be affecting large areas. And prima facie, even though our codes are prescriptive only as of now mostly, what I feel is that if they had been followed in word and spirit, they are able to maintain a good degree, they are able to give us good degree of durability over a long period of time, at least for the desired life of the structure. It is where we lack in most cases in their implementation in the field level, and that creates the problem in most cases.
So two very important things you pointed out. It's very important to test the materials, and the workmanship has to be good. The engineers have to make sure that the spirit of the standards is being followed.
Absolutely.
But how do you think, I mean, you have been the DG of probably the largest organization doing construction in India. How do you think those things have changed? How do you think those things have changed over the years?
I would say the sensitivity definitely has increased. People are learning more and more, but it's really sad to see off and on, even now, one or two projects here and there coming out with this kind of thing. I can only say we have to continue with the tighter quality control measures, independent quality testing. We involve NCCBM and such institutes, independent institutes, in many of our projects, and that I think should be done on a wider scale. That's what I can say. Because, I mean, one would expect the site engineers themselves to know and implement all this, but it is not happening in some cases.
So how have you seen the skills have changed of the engineers and the workers?
Definitely, people are definitely much more aware of these things now, and the implementation. In fact, in CPWD, we are now using, like I mentioned about water, we are using even RO water in many cases. We have established plants, made it mandatory, and it is being done. Earlier, people were not even bothering, just using groundwater without even testing it. So there is a whole lot of difference in the last, but that has taken place over the last like 20, 30 years. In my service period, I have seen this change. Yeah, for the better only, I would say.
Thank you, sir. That's good to know that the practices are improving, even though we are facing probably bigger challenges right now, which is why maybe we hear more about problems and deterioration happening. But along with that practice, the approaches to improve our design also have to change, and we are talking about performance-based design. I go to Professor KVL Subramaniam. So what do you think will change? What is the difference, and how do you think that will change things if we go from a prescriptive kind of an approach to a performance-based design?
Okay. Am I clear? Yeah.
You'll have to hold it.
Okay. Well, yeah. So this is a radical shift in the way that we would be implementing things. So with the prescriptive approach, the one that at least most of us were brought up on, the way we designed our structures, the way we made our concrete, it was always thou shalt do this. And somehow that, if you followed it, it is implied that the concrete that you made, the structures that you designed, the structures that you constructed were going to give you long-lasting performance. Somehow it was implied in there that the performance is built into it. And we've seen over the past few years that the codes and the way that these things are done are not satisfying the performance aspect of it. And when we say performance aspect of it, we are talking about like what you said, you want the long-term performance. You want the structure to deliver a certain level of performance over the longer horizon. Or what if we totally turn the design around and change the paradigm and say, instead of starting and looking at the design today, why don't we start at the end point and work our way backwards? So I now start structure for a certain life and work my way back, which means that I have to be able to bring in the performance aspect of the structure, be able to assess the performance, and then work my way back and build that in the design. So this is a totally different way of looking at design. And so this is going to bring about a radical change. And of course, from different perspectives, that would require total re-education of the whole team of engineers, of how they look at materials, how they look at structures, how do we do design. And the whole point is to ensure performance. Now we are not looking at prescriptive things. That is, I'm not looking at concrete and just saying that, look, I'm going to look at only strength, and somehow strength is implied to, or strength is tied to performance. And this whole common notion that if you're going to make it stronger, it is going to be more durable, it is perform longer, that the window. You can have normal grade concretes that will perform well over the long run, and I can start putting in issues of using material more efficiently. But with this, like you said, what is going to change? Well, the whole system is going to change. How do we evaluate these things? Which means now we need better testing protocols. The evaluation, how do I evaluate it? And change the whole design system to start working my way backwards. Now I start thinking about a structure of giving me a certain level of performance over a certain period of time and work my way backwards to the starting point and then design it at that point. So that's a whole new way of thinking. And I'm kind of glad that we are finally looking at our design, changing the design codes to address that issue.
So, you know, we as professors are feel very happy when we give out of syllabus questions. And we have these syllabus that we have in our hands. So I'm going to play that trick to another co-professor here, Professor Subramaniam. This is out of syllabus question for you.
Okay.
So, I mean, yes, that's very interesting that you're saying you have to calculate backwards. But if you want to calculate the design of a beam section, you say 0.36 FCK, BXU, whatever, and then you know that is the capacity of the beam. Do we have the data? Do we have the equations, the models to be able to do what you're saying we have to do?
That is where the challenge is, that we do not have all the information with us at this point of time. But unless we start thinking about it, we're never going to implement it. Because everything that we've done so far is to project our way forward, and we're still grappling with understanding of several of these long-term issues. But if we were to change our thought process to look and address the issue saying that I'll start from a certain service life and work my way backwards and include it in my design today, then automatically the research will go in that direction, where we will bring information to help us populate our code, to develop the sense of reliability that we would need in our codes. All of that will happen automatically. So unless the need is created, unless there's a push, it's not going to happen.
So the research is needed, the development is needed, the engineers need to work out the formula. We need to get the experience, and that's where one of the problems comes. I'll ask a question to Professor S.K. Singh from CBRI Roorkee. We have a lot of experience in Portland cement. We celebrated 200 years of Portland cement this year. But a lot of people think when we reduce clinker in our cement, the rest of the things we are adding is garbage. garbage like fly ash, we have been adding for 50 years, getting very good results out of that. Things that people call garbage but have worked for a long time. And today for sustainability, we are adding more and more of supplementary cementitious materials in our concrete. Our experience is mainly based on ordinary Portland cement. How do we overcome that? How do we choose the right cements? How do we choose the right supplementary cementitious materials and their combinations to be able to get something that we can design for durability?
Thank you, Professor Bishnoi. And you have rightly said that if you look back to 90s, early 90s, 94, so at that time, fly has been considered as a toxic material, and people are not being very keen to utilize into the binders or concrete or anywhere. We can recall we have been interacting with the Professor P.K. Mehta, and he was promoting, because this is the time, and this fly ash or other supplementary cementitious material is going to play an important role. Definitely, different type of supplementary cementitious material like fly ash, GGBFS, silica fume, and others, many. It is not only, that enhancing the durability parameters, but it is being promoting towards the sustainability. That several studies has been carried out by contradicting to each other, but definitely it has been found that overall, that it is enhancing the durability, it is being better performing in chemical attacks, it is being reducing the pore sizes, it is being, that strength development in a longer period, it is being better, and other properties is being incorporated. So, if you look into that, the days it has come up that we have to use the SCM into the cement as well as into the concrete. Definitely, Professor Bishnoi, yesterday you have told that there might be few challenges. Some issues may come where, that some capillary, that other things may issues come. But, that if you look into the long-term performance and other things, definitely it is going to play, SCM is going to play a very important role into the performance-based design. Because, that if you talk about the performance-based design means, we have been considering or concentrating towards the durability aspects, and this durability will be come up with that. And definitely we agree with the Professor KVL that we have to work out what type of factors for different durability and in a codal provision which is being given in a prescriptive format, and we have to make changes. Definitely the design engineer has to work more and more, and as a material scientist we have to provide the different factors, different systems. So by this way, SCM is going to play a very important role, particularly in performance-based design parameter.
So Singh Saab is telling me that please don't call it garbage. It is very good. That is what Singh Saab is saying. And that is what we've been hearing for the last 3 days as well. So many presentations on use of these supplementary cementitious materials, low clinker cement, right? Right, Singh Saab?
Yes, yes, definitely so.
And we have to move in that direction.
Exactly.
But the engineers have to be aware of what has to be done with each thing.
So, that I can recall, because we are doing a lot of projects with the CPWD and other organizations who is been executing. Rather than I was also being time in National Highways Authority for 5 years as a heading the project. So, that until unless we are working with the particular material, we don't know its properties, its behavior. So, conventionally what, that our predecessors are doing, so we are being dependent on that. And if you have to do, so come up with the new material, if you have a little bit of zeal, and then you can have, I can recall in year 2000, when I was in NHAI Agra, and I have recycled the existing, that nowadays it is being known FDR and other things, full depth recycling of bituminous things, and I have done in way back with the reticent equipment, and we have given a provisions. Also, that in Allahabad bridge, STU and other things, first time in India, we have used the controlled sinking of well. So if you have a little bit, okay, so you can go ahead with that. So that was not an issue. So as you have rightly said yesterday in your lectures, because that uh, these newer materials. You could not stop been looking into particular something. And I can recall previous secretary to Ministry of Housing, Durga Shankar Misra, when he was talking about prefab buildings, etc. And he was visiting at that time to CBRI Roorkee. Let open your door, windows, and let some light should come, some air should come. Only you can practicize this type of new materials, new system, new technology. So that definitely, sir.
Definitely, thank you. But there's another challenge. Of course, the engineers have to learn these things, but the challenge is 65% of the market in India is IHB segment, the individual home builder. And Dr. Ramachandra knows I'm going to ask him this question because he's from UltraTech, biggest cement producer, huge concrete producer. So Dr. Ramachandra, what can you do to make sure that the IHB segment is doing the right thing?
Am I audible? Shashank, this IHP segment from the cement consumption point of view, they consume about 65% of the cement even today. Therefore, who is ruling this segment? The masons. Very rarely, engineers are involved. Engineers may plan and give them. Masons do the whole construction. Now, when masons do the whole construction, try telling them some simple things. Forget about getting switched. Yeah. Try telling them some simple things like if you are making concrete, your water cement ratio should be less. In fact, I tried telling masons somewhere. Then they said, then he said, look, I have constructed 25 buildings or 25 years I have worked, and my father has worked for 45 years. And we are used to putting more water in cement and less water during curing. I tried to tell him that it is actually the reverse. He said, no, none of my buildings have collapsed or failed or whatever. They are all living. I think I am not audible. I thought what I said, only masons did not listen to me, but looks like here also it is happening like that. Okay. So going ahead, whether it is prescriptive or performance-based design, massive training of masons is needed today, particularly in the individual house building segment. Not just with respect to concrete, but also with respect to concrete cover, providing stirrups, bending stirrups or making the hooks at 90 degrees. This is what you see whenever you visit these houses being constructed. You will see they bend it at 90 degrees, not at 135 degrees. And you ask them to place reinforcement in the beam standing on the slab, place say in the beams 4 bars in the first layer and 4 bars in the second layer. The first layer of 4 bars will be there, but the second layer would be almost at the center, at the neutral axis. You tend to think that you have designed an over-reinforced section, but it will be very heavily under-reinforced. Therefore, training of masons and workmen plays a very important role, whether it is BMTPC or BIS also. ICA also has produced a lot of literature in different languages on good construction practices. I think this training should go on. I am not trying to be pessimistic. One example I'll give you, just before this corona started, we made some 50 videos. UltraTech made some 50 videos on different aspects of house construction from foundation to finish, and it was just put on YouTube. 1.5 lakh masons have registered during this corona time, 2 years, 2.5 years. They have gone through all of them, they have answered questions and they have passed. They have got the certificates also, because just like all of us addicted to phones, mobile phones, they are also addicted to mobile phones. And when they did not have enough work, they did a good work like this. Secondly, wherever this RMC is there, maybe we would say anything produced in the factory is better. Therefore, to that extent, wherever RMC is used, quality is slightly better. But RMCs are there in metros and capital cities and many districts, but it has not gone beyond the districts. Therefore, in the rural area, this situation continues. Now, how do we go ahead with this? We have lots of products now, other products also other than cement and RMC. Going ahead, I think more and more of precast constructions are coming up, even in rural areas. Just one or two examples I'll give you. The days are not far off when I want to just construct some 700 or 800 square feet of house, and I go to a shop, precast shop, and say that, as per the plan I have, I need some 8 columns and 12 beams and a roof of this size and so on. Maybe they would send the whole thing and it gets fitted and quality would be better. I'm also aware of one more agency called Home Mission in South, but they are coming everywhere else also, where the house is constructed, 3-dimensional house is constructed in their site, their site, not at your site. Only foundation is made at your site, and the entire house travels, maybe in pieces. They come and they assemble it in the house. Maybe going ahead, that would definitely improve the quality of construction. 3D printing also is coming, but may not be to the IHB segment right now. Therefore, these are some possibilities going ahead. Otherwise, training masons is the only way.
Thank you, Dr. Ramachandra. That means training is very important, and the industry production is probably going to have a big effect.
Yes, yes.
And the industrialization of this construction, maybe that allows the inclusion of more advanced materials, finer materials, ultra-fine materials. And I'll ask this question to Kole Saab from JSW. How do you see the future of these kind of advanced materials, nanomaterials, ultra-fine materials, and can they play a role in long-term performance? Can they really help when we go towards more industrialization of construction?
To start with this discussion, I'll go back a little bit. See, today in this conference, actually, we are taking oath, or we are proposing, or we are discussing, whatever we can say. By 2070, we are going to get or achieve this year net zero, these things. Now, this is a global challenge, and this is we have to do. This is essential now, and it is the history that time to time everything need to revisit. I mean, once upon a time I was eating roti, and once after morning I may not find the roti is the ultimate things. I have to find something else. So that cement was conventionally people are using for people's structures and all other things. But at the moment it is not the solution, because as Professor said, IIT Hyderabad, and all my predecessors said about we should look back. When once I can define my structural requirements clear, structural performance parameters requirement is clear, then I can think of different kinds of materials. Now, on the earth, a lot of materials are available, but we do not know what material can help us, which material we can use. Now, to address this industrial development and industrialization, we find a lot of waste products are there, which are also again creating a lot of problem. Now, to solve that issue, to make a circular economy and getting this very good product out of that, if we see that slag is very interesting and very good product, and in our lab we have tested that slag, even though up to 2 years we have tested, it's slowly hydrates and add on this strength. And this kind of different supplementary cementitious materials are there, which are very good. If we grind this slag up to a certain level, like your nano level or maybe fume silica level, and if we grind fly ash also in that level, these materials works in two ways. One is chemically, other one is mechanically. So this material will works both the way, and it will add on this your durability as well as this your strength factor. That if we study carefully this your concrete in plastic state and as well as hardened stage, there are a few things very important, that your packing of this your concrete and the distribution of different types of particles are there.
And even though from binders particles are there, some aggregate particles are there, and different types of aggregates are there. With that, whatever the matrix is coming, lot of voids are there, and the voids size are various ranges. It ranges from nano level to this level or so. So we need to address that in very smart way. We need to make a certain design, smart design, so that we can overcome all these things. So I will say that the alternative cementitious material, supplementary cementitious material, and some other different kinds of binders, some other different kinds of filling materials, all these things we must look at. And today's problem we cannot solve in a single solution. We have to look at number of ways, number of things, number of materials to address these all this sector's problems. And one more thing, that as a manufacturer, as a governing body, as like your BIS, NCCBM, these kind of government sectors, no one can give a complete solution. It's the time actually, all these people, all the stakeholders, and all these responsible people across this chain, they should work together so that we can address, we can solve this problem. So in a nutshell, the strength is not the final word, durability is the final word. To address the durability, whether I am talking about durability correctly, or I am getting this your data correctly or not, we may have go to different kind of testings, like your microstructures, this your analysis, we have to go for porosity analysis, we have to go for RCPT, we have to go for RCMT. Number of testers are the carbonation testing, lot of things are there. Yes, to use this kind of materials, as you only yesterday, you are presenting this paper, you said that this slag, particularly when you pass this carbon dioxide, it absorbs mostly. And after absorption, this carbon dioxide, it's producing calcium carbonate, and at a nutshell, it's giving this carbonation issue. Yes, carbonation issue is there in slag, but it can be addressed. And one light you have given, that some waterproofing chemicals. So that waterproofing chemicals can address this. We have developed one waterproofing cement in JSW cement that addressed, we have addressed that issue. So maybe some challenges are there, but for that challenge, we should not sit back. We must work hard. We must get this challenge. We must take this challenge for this solution.
Thank you, Kole sahab. We have been informed that the chief guest is here for the function. So what we will do is, I will ask a last question to Ojha sahab, and we'll wind up the panel discussion over here. Ojha sahab, those are very challenging requirements. Do you think we can even make standards for something like that? Because we are saying we can add all kinds of different things, finer things, industrial production, home production, all low clinker cements. Is it even possible to standardize so much variation in materials, so much variation in practices, and bring them into a document that people will be able to use?
So for this answer, we should define what is the meaning of durability of concrete. So design for durability. So design for durability means is, when you are designing for load, you know two things: the load coming over it, converting into a stresses, and the response by the structural member to those stresses. But what is the durability design? When you say durability, third dimension, time comes. So that performance should be maintained over a period of time. And for any durability, the mathematical equation should be available for a particular deterioration mechanism with respect to time. So whether we should know mathematical model is available or not. So for further clarity, the design means for load, we are designing for compression, shear, torsion, bending, like that. Here, whether designing for corrosion, against corrosion, designing for carbonation-induced corrosion, or chloride-induced corrosion, or against sulfate attack, or against alkali silica reaction, or against acid attack, for which deterioration, or two type of deterioration simultaneously, for which? For some of them, we have a mathematical model available, like we have a widely acceptable carbonation-induced corrosion model, and we have an equation available where we can relate the cover concrete with the weather coefficient, carbonation coefficient along with time. So using that mathematical model, we can design a particular structure with a particular type of cementitious material, with a particular cover and a particular cross-sectional area for a particular service life when we are calling it durability. So this is the meaning of durability. Similarly, we can design for chloride-induced corrosion because we have a widely acceptable model with a little bit corrections in that model where we are integrating it, whatever the initial chloride content in the concrete, what is the chloride coming over it, what is the chloride available at surface, what cementitious materials we are choosing, and what is the chloride diffusion coefficient. So integrating all those in a mathematical model, we can choose the appropriate cementitious system where we can choose the concrete cover depth also for a particular service life also, and we can get the performance what we can prescribe and for which we can design. So it is available for carbonation and chloride induced corrosion, but this is not available for sulfate attack. So here in our standard, even in the standard which we are drafting, again we are classifying the different sulfate attack and its severity, but we are converting into dim to satisfy method only. For alkali silica reactions, whatever is in existing standard, we are sticking with that a little bit more method, avoidance of deterioration method. So now in our standard, what we are doing is we are classifying the load, environmental load. In present standard, if you will see, the class exposure condition is mild, moderate, severe, very severe, and extreme. And this is a very generic. It's not, as you said, the paracetamol will not work for every problem. So similarly, for every type of exposure, it cannot be classified mild, moderate, severe, very severe, and extreme. So for carbonation, C1, C2, C3, C4, we are classifying it. For chloride, we are classifying it SW1, SW2, SW3, further SW1, A, B, C, depending upon the distance from the coastal area. On the chloride content, what is in the middle of the land, we are classifying it. So for carbonation-induced corrosion and chloride-induced corrosion, we have a mathematical model which is widely acceptable among the researchers. Adopting this, it is possible to have a prescriptive, not prescriptive, but performance-based design.
I'm sorry, I'm cutting you off.
Yes.
But those are perfect words to end this panel discussion because I am being told again and again to stop. But those are perfect words because what you're saying, it is possible. That's how I want to conclude from what everybody has said. It is possible. It is important to have good workmanship, good training, good knowledge. Engineers should know about material, industrialization, research, and experimental data for all of those things, and good quality materials also you mentioned. So let us end over there. Maybe I'm sorry for cutting you off today like this, but thank you so much. Thank you everybody for listening to us.
Thank you very much.
Thank you very much, Bishnoi sir. Thank you very much all distinguished panelists. It is always pleasure to listen seasoned and experienced panelists like you. Now I request Mr. Christopher Ravi to come on dais and present the mementos to our panelist and moderator. करो. So, all delegates are requested to please take next hall AB, where we are starting the concluding session. For the concluding session, please take your seat in hall AB.